So, question 11. And we've got a guitar and a standing wave. So you know all about harmonics and standing waves. And this is on a fixed string. So you'd have nodes there and antinodes at the kind of peaks. Give the missing label for the y-axis. So this is displacement, so moving away. It moves both ways. So displacement. So remember, you might remember a Jelly Baby machine, wave machine, how far the Jelly Baby moves away from its equilibrium position. And label N1 node. Oh, very good. Well, we can go N, capital N, capital N, capital N, capital N, there we are. We don't have to do one of those. The antinodes are up there, so any one of those ends will do. A guitar string is tuned by changing the tension, and it gives us speed and mass per unit length. Calculate the tension. Right, okay. So you're given this equation at the back of the book. So at the back you've got your periodic table. Oh, there's some, and that's the one we want. So V equals the square root of T over mu. V equals the square root of T over mu. What have we got already? So the speed of a wave, so that is V. Mass per unit length, that is mu. Calculate the tension. There's a couple of different ways around you can do this. I prefer to rearrange the equation, then stick the numbers in, but you could stick the numbers in, then rearrange it. So what I'm going to do first is I'm going to get rid of this square root. We want T on its own, so I'm going to get rid of this square root first. But I've got to, if I do this, if I just do that, then I've got to square the other side. But now I want to get rid of this mu, so I'm going to move that up, so V squared times by mu equals T. So I'm just going to swap that around. And now I can stick in the numbers. And we've got V squared equals, so we've got 16.2 times by 16.2 times by 0.3. And when I do that, we have 16.2 times by 16.2 times by 0.3. 16.2 times by 16.2 times by 0.3. 78.732. 78.732, and because we're getting one decimal place there, or three significant figures for the best one there, 78.7. And do we have a unit? We will have a tension, so that is going to be newtons. There's a unit anyway. Isn't it helpful? 78.7.